I'm just not getting in. You lousy Wi-Fi. Like I'm in, but it won't load.
I saw the AT&T guy here, so I hope he's not going to mess anything up.
Whoops.
I hope. I hope he doesn't mess anything up.
Cross your fingers.
Yep.
No, usually they just turn it off.
Okay.
Just turn it back on.
Okay, so this is page 503 in your brand new math book. Page 503, we're talking about powers and exponents. A product of a like factors can be written in exponential form using an exponent and a base. The base is the number used as a factor, and the exponent tells you how many times a base is used as a factor. Fill in the boxes with the words factors, exponent, and base. So if you look at that expression there, 10 times 10 is equal to 10 to the second power. These two 10s are both factors. Okay? This number here is your base, and 2 is your exponent. Okay? So this is saying that it's just a shorthand form of, rather than writing 10 times 10, you can write 10 to the second power. Can I help you, gentlemen?
You have a computer sign right?
On the window?
Yeah.
Yeah, sure.
We'll take it off.
Yeah, sure. You're going to have to roll up the blinds. You got tape?
Yeah, we got
Okay. Can you get to it? Can you pull up the blind? You may have to pull the chairs out. So it says, give an example of an exponent. So if I were to give you another example, like 4 to the second power, this is your base, and this is your exponent. Okay, it says write the definition of an exponent in your own words, right? So an exponent, thank you. An exponent tells how many times the base is used as a factor. Okay, so that's what the definition of an exponent is. Okay, so if we go to the real world, it says an MP3 player. MP3 players come in different storage sizes, such as 2 gigabytes, 4 gigabytes, or 16, where gigabyte means gigabyte. 1 gigabyte is equal to 10. Sorry, 10 times 10, anywhere there's 9 of them. So 10 times 10, 9 times is equal to 1 gigabyte. These are bytes, right? So what is the number written as exponents? That would be written as 10, because 10 is your base, and 9. So 10 to the 9th power tells you how many bytes are in a gigabyte. I can remember when we didn't have gigabytes. We just had bytes. That's how far computers have come. Okay, page 504. Okay, so now numbers expressed using exponents are called powers. For example, 100 is a power of 10 because it can be written as 10 to the second power. Numbers like 100 are called perfect squares because they are the squares of whole numbers. Okay, so when you see a little 2, You can say it either way. You can say 10 to the second power, or you can say 10 squared. It's just a shortened way, right? Instead of saying to the second power, you can say 10 squared, but it's the same thing. So in this example here, right, I have 10 times 10, so there's 100 squares in this square. I can also write it as 10 squared, or 10 to the second power, which is equivalent to 10 times 10, or 100. So 10 to the second power, 10 squared, is 100, and 10 times 10 is 100, okay? Now in this diagram here, this is a 3D figure, so we have 3 different dimensions, right? Over here, we just have length times width, right? You only have 2 dimensions. Here you have 3 dimensions. You have length times width times height, 3 different dimensions, right? And so you have 3 tens, because you have 10 here, and 10 up there, right? And 10 times 10 times 10 is 1,000. And if you also notice, you can just count your zeros, right? And that's how many zeros you have in your product, right? Similarly here, right? You have 2 zeros here, and in your product you have 2 zeros. So this could be written as 10, they call it cubed. You can say 10 cubed or 10 to the third power, whichever. Cubed is shorter. Perfect cubes are numbers with 3 identical whole number factors, such as 4 times 4 times 4 is 64. The number 64 is a perfect cube, so you can say 4 cubed. You can generate equivalent expressions using whole number exponents. Equivalent expressions have the same value. So they're just saying that's just another way you can write that expression. Okay, so here's an example. For each of the following, generate an equivalent expression using an exponent. So I have 6 times 6 times 6 times 6. 6 is my base, right? And how many do I have? I have 1, 2, 3, 4. So it's 6 to the 4th power. Or you can say 6 is used as or you're using 6 as a factor 4 times. Okay. Here, number 2, you have 4 times 4 times 4. Right? The factor 4 is your base. This is your base. The factor is multiplied how many times? 3 times. The exponent is 3. So 4 times 4 times 4 can be written as 4 cubed, or you can say 4 to the third power. Okay, so here at the bottom it says for each of the following, generate an equivalent expression using an exponent. So go ahead and write A with an exponent. Your base is 7, and then your exponent, and B, your base is 9, and your exponent. All you have to do is count it. Right, so you have 1, 2, 3, 4. So that's 7 to the 4th power. Then 9, you have 1, 2, 3, 4, 5, 6, 7. So that's 9 to the 7th power. Much easier to write this than it is to write this. You'll see a lot more of this in physics and science, the big upper level science, because they work with very big numbers. Okay, page 505. To write powers as equivalent products, determine the base and the exponent. The base of 10 to the 10 squared, or 10 to the second power, is 10, and the exponent is 2. To read the powers, consider the exponent. The power 10 to the second, or 10 squared, is read as 10 squared, and 10 to with the 3 is read as 10 cubed. Okay, those are the only 2 that you say something different. So if you see a 2, it's squared. And if you see a 3, it's cubed. And if you kind of think of these two shapes over here, it sort of makes sense, right? This is a square and this is a cube. Okay. But there's nothing wrong with saying 10 to the second power. You can do that. Okay, number 3, I have 5 to the second power, or 5 squared, as a product of the same factor, then determine the value. So the base is 5, the exponent is 2. So 5 is used as a factor 2 times. So 5 squared is the same thing, or equivalent to 5 times 5, and 5 times 5 is 25. Okay. Now they're going to do it with it. You can also do this with a decimal. So express 1.5 cubed as a product of the same factor, then determine the value. So the base is 1.5. The exponent is 3. So 1.5 is used as a factor 3 times. So 1.5 cubed is equal to 1.5 times 1.5 times 1.5, and you get 33.75. Okay. You can also do the same thing with a fraction. So express 1/2 cubed as a product of the same factor, then determine the value. The base is 1/2. The exponent is 3. So 1/2 is used as a factor 3 times. So you can write it as 1/2 cubed is equal to 1/2 times 1/2 times 1/2. And remember, is when you multiply fractions, you multiply all the denominators together, numerators together, and all the denominators. So 1 times 1 times 1 is 1, and 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. Okay? So you can do this with fractions. You can do this with decimals. And you can do this with whole numbers. Okay? Okay? So at the bottom it says express each power as a product of the same factor, then determine the value. Okay? So once you take some time, once you go ahead and write out 10 to the 5th power, and then find the product, then you have 2.1 squared, and then you have 1/4 squared. So why don't you go ahead and work on that and see what you get as an answer. Hey Google, set a timer for 1 minute. I guess Google's not working. Okay. I'll do it the old-fashioned way. Okay, so C, right, we have 10 to the 5th power. So if we were to write that out, that would be 10 times 10 times 10 times 10 times 10, right? Now you could do all the multiplication, right, which would be rather time consuming. But this is all factors of 10. So actually you can just take the 1. How many zeros do you have? You have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So that's 100,000, right? Okay, so your answer for C is 100,000. Okay, D, so if you expanded that out, that'd be 2.1 times 2.1, right? Well, 2.1 times 2.1. 1 times 1 is 1. 1 times 2 is 2. 2 times 1 is 2. 2 times 2 is 4. Bring down the 1. 2 and 2 is 4. Bring down the other 4. But you have two decimal places. So that's 1, 2. So this is equal to 4.41. So your answer for D is 4.41. Now you've got 1/4 squared. So that's 1/4 times 1/4. And with fractions, you multiply the numerators across. So 1 times 1 is 1. 4 times 4 is 16. So your answer for E is 1/16. Okay. So the other classes, they were complaining they didn't have enough time and they want to do the Ed puzzle. How many people have done the Ed puzzle for math already? Okay, 2 people. Okay. Since I want to make sure we get everything done by the end of the week, I'm going to let you use the last 20 minutes to do your Ed puzzle, your math Ed puzzle. If you've already done your Ed puzzle, then there's other stuff you can do in your packet if you haven't finished your packet. Okay? So once you go ahead and take the next 20 minutes, do your Ed puzzle in math, and then work on anything else you have left in your packet. Okay? And we'll do a little bit more of this tomorrow. What's tomorrow? Wednesday? Yeah, we'll finish this up Wednesday and set you up for the quiz. This is going to be another easy one. And then we'll be ready for our math lab on Thursday, Pi Day. If you have any stuff done, you can bring it to me and I'll mark you off. So this is Christian. Christian is math minute 20. Math detective 33. Yes, ma'am. Oh, you don't need it anymore? Okay.
Yeah, I have mine in the account. I'll just
Cool.
Not so there's some stuff in the packet.
Okay. What you got?
The math minute?
Math minute. Yep.
Yeah, I didn't do the math check of that. I did the
Sudoku, okay.
I started it. Yeah.
That's it?
Yeah.
Okay, cool. Yes, ma'am.
Math minute.
Math minute. Math
Any
detect.
help on this one right here? Like, what are we supposed to do with that thing?
Says using the drawing you made, fill out this list to show how many branches are in each generation. The first is done for you. Oh. So I think what you do is you draw another 2, and then you draw another 2, and you draw another 2. Is that what it says? Only a little branch. I'm sure. Okay, when the children got home, the grandfather drew a picture of 2 times 2 times 2 times 2. Then he said, this is also written as 2 to the 4th, and 2 is called the base. So you're just going to go 2 here, and then you're going to go 2 more. Does that make sense?
Thank you.
Uh-huh. Okay. Oh, he didn't do that. Okay. Math minute 20. Math minute 21. Didn't do that. I assume we did the quiz. Okay. Yes, sir.
I did my last minute.
Sam, last minute. And that's effective. Okay.
And that's it.
Okay. Thank you.
did 38. I don't know if that's this week.
I'll write it down. So
38.
math detective 38?
Yeah.
Okay, I got you. Thank you. Yes, ma'am.
I think I finished everything.
Okay, so math. Yep. Excellent. 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 Okay. Good deal. I got you. Thank you, ma'am. Science detective, your period 1, period 3?
Yeah,
Good.
period
Science detective. Gotcha. Beautiful. Awesome. Great job. Thank you. Okay, guys, it is 2:09. That is the end of period 6. You may log off and go to period 7.